All right. So the important thing is that you get this conclusion in here. Okay. So what can you see about f prime? That's in this box here, or the black box, or the red box. It's positive. So this is greater than 0. And the blue one's going to be negative, less than 0. Okay? So in other words, when the function is increasing, okay, f prime is going to be positive. When the function is decreasing, f prime is going to be negative. Okay? Guys, got that concept? So that's using calculus as opposed to what we did in pre-calc. Okay? In pre-calc, we just looked at the picture and said, yeah, this is increasing, this is decreasing. Okay? Right? You guys with me on that? And in words. Okay? In words. Okay, you guys got this down? Yep. Okay, so an example. So as soon as you see critical numbers, what should you be doing? Thank you. Should be getting a derivative. Okay, so derivative f prime of x. Someone help me out. Minus what? Minus 6x. And then what do we need to do? Set it equal to 0. So we need to factor this guy. And your critical numbers are 0 and 2. So once you get the critical numbers, you want to put it on the x-axis. Okay, here's 0 and here's 2. Okay, so what those two critical numbers do is break up the x-axis into 3 regions. Okay, into 3 regions. One from negative infinity to 0, the other from 0 to 2, and the third from 2 to infinity. Right? So you get critical numbers, put it on the x-axis. Okay? What I'm trying to do is I'm going to try and sketch a graph. Okay? When I say sketch, it's not going to be precise in this case. Okay? Because I have no clue about what's happening to the y, what the y value is at a particular point. But I can certainly tell you whether the function is increasing or decreasing from what we just learned. Okay? I should be able to tell you that. So, sorry? No, this will be parentheses because at 0, at the extreme points, things are neither increasing nor decreasing, right? They're neither increasing nor decreasing at these critical numbers, right? Because the derivative is 0. Okay, so between negative infinity and 0, pick a test point. Pick a number. Negative 1. Put it in this factored form of f prime. And then tell me whether the result is negative or positive. Sorry? Positive. Function increasing or decreasing? Pick a number between 0 and 2. Put it in f prime. Positive or negative? Increasing or decreasing? Number between 2 and infinity? Okay. Put it in f prime. Positive or negative? Increasing or decreasing? Is everybody with me on this? Yeah? Now I want to sketch a graph on this because I know whether the function is increasing or decreasing. Okay? And where you start out on the y value doesn't particularly matter. I want the shape of it. That's all I want. Okay? So I know the function starting out minus infinity to 0, it's increasing. So it's going to be going up, up and up and up and up until I get to x equals 0. Okay? And then it's going to decrease, right? So we already did this. Then it's going to go decrease. So it's going to turn around. Okay? And it's going to continue decreasing until I hit my next critical number, which is out here. And at that point, it's going to increase. All right? So notice that my y value, I have no clue as to whether this is a 3 or a 5 or an 8. Okay? But the shape is what all I'm interested in. Okay? And where the turning happens. So notice that at the critical numbers, the tangent line is vertical. Yes. Oh my God, you guys smoke so much. I smoke a lot. It's secondhand smoke. If you see any damage from me, it's all secondhand smoke. It's from you guys. Haha. Okay, so at the critical number, the tangent line is going to be horizontal, which will give you either a max or a min. We did this yesterday. Some of us did it yesterday. Okay, not all. Some of us did it yesterday. Okay. All right, you guys get the idea of how to graph using increasing, decreasing concept. Yes. At the critical number, the tangent line is horizontal.
Okay, yeah. You want it to, okay, that's it.
Just know it. Just know it. Okay, guess what? Oh, someone smart. All right, so what I'd like to do now is move on to what's called the first derivative test. Okay, the first derivative test. I need to kind of make this a little smaller because I need to have two boxes in here. So I'm going to make this like, hopefully you guys can see this because I need both the boxes in there on one screenshot. Okay, I'll pause here for a minute. Okay. All right, so you should have gotten f prime in a factored form like that. So you get your critical numbers are equal to -1, 0, and 1. Those are your three critical numbers. Okay? Now what I want you to do is think of a number that's little less than -1, a little less than -1. Put it in this equation here and tell me whether the quantity is going to be negative or positive. Okay, you don't have to work the whole thing out. All you need to do is think about whether it's going to be positive or negative. So when I put x is little less than -1, this quantity is going to be negative. This is negative. This is also negative. Three negatives make a negative. So this guy is going to be negative. On the other side, okay, this is going to be negative because it's a little bit more than -1, so like -0.9. So that's negative. This is negative, and this is positive. Two negatives make a positive. Okay. You need to pay attention, be focused here. Okay. Pick a number to the right of -1. A little bit to the right. -0.9. If you put it in here, that's a negative quantity. If you put it in x, that's negative. This is negative. This is positive. Two negatives make a right there. Okay? Take a number a little less than 0, -0.1, let's say. This is negative. This is negative. This is positive. That makes it a positive. The other side is going to be a negative. And now a number little less than 1, put it in here. It's positive, negative, positive, negative. And then to the right, it'll be positive. So looking at Laura's graph, you can see that the tangent is going from a negative to a positive. See that? What does that result in? This guy? What's happening to the tangent? Positive to negative. And then this one here. Not at that point, I'm looking. That's why you're going to the left and to the right. Okay? So here, this guy is min, max, min. The tangent is going from a negative to a positive. Negative to a positive. Can you fill in the sparkles now? So, just a hint, sparkles have to have one of these two thingies in there. So it changes from a negative to a positive, then this guy is going to be a min. And going from a positive to a negative is going to give you a max. That's called the first derivative test. Called the first derivative test. If there was one, why would I want to call it first? I would call it the derivative test. There are two, because then next week or the week after we do the second derivative test. Okay? All right, everybody get the idea of what a first derivative test is doing? It's just looking at the slope of the tangent around the critical number. So if it changes from a negative to a positive, it becomes a min. I almost sound like Jaime Escalante in that movie. Don't I sound like that? A positive and a positive gives you a... sounds just like him. Yeah, I think you're right. Kind of channeling that guy. Did we not have a conversation yesterday that I said that we might do it next week on Tuesday? Did I not say that? The back row is full of smoke. Even though there's a no smoking sign on the back of the room there, it's still filled with smokers. Okay, you got the first derivative test. I want you to look at page 181, and there's a place where either to the left or to the right of the critical number, the slope doesn't change sign. In other words, it's negative on both sides or it's positive on both sides. If that's the case, then you don't get a min or a max, but you get what's called a point of inflection that we'll learn about a little bit more later on. Okay? But I want you to take a look at the pictures on page 181 that are in that box, particularly the bottom two pictures there that show you the points of inflection, what they look like. Eric, dare you open your book? Dare you borrow it from your neighbor? Dare you look over Michelle's shoulder? I guess you can't borrow the book from anybody because nobody in that hood's got a book. Oh, Inez got one. That's not the hood then. Yeah, I just gave a lecture to my first period class that you won't believe it or not, I started teaching when I was 17 years old. I was actually a high school graduate and I started teaching for a bit before I went on to college. And I had a student back then, this is in Africa, okay, in Kenya. And I had a student who walked 6 miles each way to come to my class every day. Wow. Every day. So you were like this. So, and then in the other period there was Christian, okay, Christian Salvan. And, you know, he's a wisecrack, right? So he says, yeah, and he went uphill both ways, right? So yes, he went uphill both ways.